Hello, welcome to this video. In this video, let us derive an equation for volumetric efficiency of a single stage compressor with clearance volume. Okay. Now I have taken a PV diagram with clearance volume, and we already know that effective swept volume is between V1 and V4. So this will be our V1 minus V4, and we can also say this is our clearance volume, that is V3 is our clearance volume. So we can write that this is our clearance volume. Okay. So this is our clearance volume Vc. And we can also write this total swept volume. So total swept volume is happening between V1 and V3. So this will be our swept volume. Now let us start from the definition of volumetric efficiency. So volumetric efficiency is given by effective swept volume divided by swept volume. Now what is effective swept volume? Effective swept volume is V1 minus V4. Okay. Now V1 if you see, now V1 is from total, that is from here to here. So this is our V1. So V1 can be rewritten as, so I will rewrite, because V1 is equal to Vc plus Vs. I mean V1 can be written as Vc plus Vs. So Vc plus Vs is written in place of V1 minus V4 divided by Vs. Now what I can do is I will take this 1 by Vs common out here, and then I can also take in the numerator, I will take Vc as common. So if I take Vc as common, then in the first term we will have only 1. Okay. So in the second term it will be Vs by Vc minus it will be V4 by Vc. So Vc by Vs I have taken out common. So now our volumetric efficiency Vc by Vs 1 plus, now let us define what we call it as clearance ratio. Now clearance ratio is the ratio of clearance volume to the swept volume. I will call this as capital C. Okay. Now capital C. Now since Vc by Vs is our clearance ratio, now this will become 1 by C, 1 by capital C, minus this I will rewrite it as same V4 by Vc. Now what is this V4 by Vc can be written as? I will simplify it here. We are talking about somewhere between 3 and 4, right? Because Vc is clearance volume, that is V3, and V4 is the point where this is where 3 and 4 is. So I will consider a process from process P3, I mean process 3 to 4, alright. From process 3 to 4, I can write P3 V3 power n is equal to P4 V4 power n. Okay. Now what is this P3 V3 power n can be rewritten as, I mean I will take, we want V4 by Vc, so I will go for V4 by V3 on one side, this whole power n is there, and this comes to the other side, so P3 by P4 on the left side. So this is what is our expression. Now what is P3 by P4? P3 and P2 are same. So we know that P3 is equal to P2 and P4 is equal to P1. Actually we are talking about pressure ratio, that is what we mean. So let us write it as P2 by P1 if you want to, and this will be V4 by, now that is nothing but V3 is equal to Vc, right? So V3 is equal to clearance volume Vc. So this power n comes to the other side 1 by n. So this is nothing but Rp power 1 by n. So what we mean to say is V4 by Vc can be written as Rp power 1 by n. So because V4 by Vc, let us call this as expression 1, from equation 1, V4 by Vc can be written as Rp power 1 by n. Okay. Now again this can be further written as Vc by Vs already we have defined, let us call it as C. Then this will be 1 plus 1 by C minus Rp power 1 by n. Now this, let us multiply this C again back inside. So we will have C plus 1 minus C Rp power 1 by n. Okay. Now regroup it so that we will write C on one side. So 1 plus, if I take C common in these two, it will be 1 minus, so 1 plus C, if I take 1 minus Rp power 1 by n. So this will be our volumetric expression, volumetric equation. Or we can also write the same expression in a different form, because we would like to keep it Rp power 1 by n first. Nothing is changing, we are just rearranging so that meaning doesn't change. So 1 minus C into Rp power 1 by n minus 1. The same equation is rewritten just without changing the meaning of it, alright, which will give me the same answer. So we can use any one of these expressions to get volumetric efficiency of a single stage compressor with clearance volume. We'll see you in the next video. Thank you.